Hey guys, Mr. Bowman here. Today's learning objective is in blue and we are learning to apply basic angle properties. And I'm going to underline that word apply because that's the key thing we're looking at to do today. So just to recap, in the angle type video, we learned there are things called acute angles, right angles. One after that, hopefully you remember, obtuse. We then had straight lines. We then had reflex angles after that, and the final one we had was that full revolution. So today we're carrying on with some of these. I'm actually going to cross some of them out. So I'm going to get rid of acute angles, I'm going to get rid of obtuse angles, and I'm going to get rid of reflex angles. And I'm getting rid of those because we know with certainty what the other angles are. So we know right angles are 90 degrees. We know straight lines are 180 degrees, and we know full revolutions are 360 degrees. So we can use that certainty that those three angles provide to solve geometric problems, and I've got 5 examples here with us. We're going to start off with the top 2 questions here, and the thing I'm liking about these, I can see that little right angle symbol. I know that this here is a right angle. And for a right angle, I know that all of the angles are meant to add up to 90 degrees. So we can form a bit of an equation. So I know that A, which is the angle here, plus 40 degrees is meant to equal 90 degrees. And if I go A is equal to 90 degrees minus 40 degrees, that will tell me how much angle A is meant to be. The leftover portion would have been 50 degrees. So I know that because the angles in a right angle triangle, so angles in a right angle sum to 90 degrees. So I know that with certainty. Having a look at the next one, we can see that right angle symbol there again. So I'm a big fan of that. So what I'm going to do is I'm going to go 90 degrees minus the 43, and I'm going to go minus the 24. So I know these two. I'm going to take them away from the 90, and that should leave me with a leftover, which will be B value. So this is when I'm going to grab out my calculator. So 90 minus 43 minus 24. I'm getting 23 degrees. Hopefully you're getting the same. 23 degrees. And again, I know that with certainty because angles in a right angle or angles in a right angle sum to 90 degrees. Now the next question, so we've done some stuff on right angles. The next question, what we can do or what we can see is down the middle there, we can see that's a straight line. And we know angles on a straight line are always going to sum to 180 degrees. So angle A, which we don't know, plus that 135, that's meant to come to 180. So I'm going to subtract like I have in the previous questions. I'm going to go, well, 180 minus 135, that's going to get me to 45 degrees. So I've taken away 135, that leftover portion, 45, has to be A because, and again, I'm writing some reasoning, so when you ask for reasoning, you're going to need a sentence that supports what you're doing. But my reasoning, angles on a straight line sum to 180 degrees. So I've got some reasoning there. And the final question we're looking at relates to circles. So we can kind of see the circle part there, and we can see the circle part in the next question as well. And the thing we know about circles, in a full revolution, or in a circle, there's going to be 360 degrees. So working on this side here first, I know that B plus 35 degrees, that should come to 360 degrees. I'm going to subtract that. So I'm going to go minus 35, just like I would for algebra. 360 minus 35. That means angle B there should be 360 minus 35, 325 degrees. So I know that with certainty. And in terms of a reasoning, well, how do I know that? Angles around a circle, or you might want to say around a point, or you might want to say in a full revolution, but let's stick with angles around a point, sum to 360 degrees. And we've got our final question. We don't have to do a full algebraic equation like I did here. We can just use our subtraction approach. I know this circle sums to 360. So I'm going to go 360 minus all the angles. So I'm going to go minus 69 minus 131 minus 31 minus 109. When I do that subtraction, I'm grabbing my calculator out here because I don't trust myself to do the maths right in my head. So we've got 360 minus 69 minus 131 minus 31 minus 109. Hopefully you're getting the same as me. I'm getting 20 degrees. And again, it's that same reasoning. Angles around a point sum to 360 degrees. So hopefully you found this video on applying basic angle rules properly. We focused on right angles, straight lines, and full revolutions to answer geometric problems.